This video will cover the topic, solving a linear inequality with multiple instances of the variable, problem type 1. For this topic, it's important to remember that when we want to move a number from one side of an inequality to the other, we have to add its opposite. So if we were to have the example, 3x is greater than 4, we would add the opposite of 3, so negative 3, to both sides in order to move the 3 and get x by itself. When we do this, the expression becomes x is greater than 1. Another thing to remember is that in order to make the coefficient of our variable equal to 1, once we have it by itself, we can divide both sides of the inequality by the current coefficient of our variable. So say we have the following inequality. 3x is greater than 6.
We would divide by 3, right?
Right, and so the expression would turn into x is greater than 2. One last thing is that if we ever multiply or divide an inequality by a negative number, we must flip the inequality sign. So if we had the following problem, negative 3x is greater than 6, we would divide both sides by a negative 3 and flip the sign. And so our final expression would become x is less than a negative 3. Let's apply these concepts in order to solve a linear inequality with multiple instances of the variable. Here we have the problem, negative 5y minus 17 is greater than 2y plus 11.
We have to get y by itself, right?
Exactly. So the first step we need to do is to pick a side to put y on.
Well, I like the left side because I'm left-handed.
Alright, so in order to get y by itself on the left side, we have to add 17 to both sides. When we do this, we get negative 5y is greater than 2y plus 28. Next, we need to add a negative 2y to both sides in order to move the y term on the right side of the inequality to the left side. When we do this, the resulting expression is negative 7y is greater than 28.
So next we divide both sides by negative 7, and our answer is y is greater than negative 4, right?
Close. You forgot to switch your signs, which we have to do because we're dividing by a negative. When we do this, our final solution is y is less than a negative 4. We can check this answer by picking any value for y that is smaller than a negative 4 and seeing if it makes the equation true. Let's choose y equals negative 5. If we put this into our original expression, it becomes negative 5 times negative 5 minus 17 is greater than 2 times negative 5 plus 11. We can simplify this down to 8 is greater than 1. This expression is true, and so our solution should be correct.
So in order to solve a linear inequality with multiple instances of the variable, we first need to get the variable term by itself on one side, then we need to make the coefficient of the variable equal to 1, remembering to flip the sign if we multiply or divide by a negative number.
Right,